Sand falls from a conveyor belt at a rate of 10 meters cubed per minute onto a top of a conical pile. The height of the pile is always 3/8 of the base's diameter. How fast are the height and the radius changing when the pile is 4 meters high? Give your answers in centimeters per minute. Okay, so we have a conical sand pile. And this is going to be a cone, and it's dropping at 10 meters cubed per minute, which means the volume over time is going to be 10. So I'm going to take this, I'm going to put this over here and leave it for later. I need to know the volume of the sand pile. Well, the volume of a sand pile that is going to be conic, is going to be 1/3 base, which is going to be pi r squared, times height. And I know that the height of the pile is always going to be 3/8 the radius. 3/8 of the base's diameter. So this is diameter. But since this is r, I need to make this r. So this is going to be 3/8 of the diameter, which is 2r. This is going to reduce with this to make it 4. So the height is going to be 3/4 r all the time. Okay, so I'm going to get rid of this. And this is going to be t. Okay, so if I take this and I plug it into here, I am going to get V equals 1/3 3/4 r squared. No, wait. Let's do that again. 1/3 pi r squared multiplied by 3/4 r. I replace this h with 3/4 r. So this is going to be 1/4 pi r cubed. Okay, so that's my v. So if I take the derivative of both sides with respect to time, I end up getting dv over dt, and that equals 1/4 pi times 3r squared, which ends up being 3/4, oh, not pi r squared, 3/4 pi r squared dr dt, because we're doing it with respect to time, not with respect to r, which ends up becoming 3/4 pi r squared dr dt. Now, we know that dv dt is 10, so 10 equals this stuff, so I get 3/4 pi, and then r squared, 4 meters high. So that means h is going to be 4. And when h is 4, r is going to be 16/3. So this is going to be 16/3 squared dr dt. That's what we're actually going to solve for. dt. All right, so if I reduce this, I end up getting 16 squared, 256. So this is 256 over 9 dr dt. And we're going to multiply that by 3/4 pi. And that equals 10. This 3 is going to go with this 3 to become 3. 256 divided by 4. 256 divided by 4 is 64. So this goes away with this and becomes 64. So we end up getting 10 equals 64/3 pi dr dt. So if I multiply both sides by 3 over 64 pi. 3 over 64 pi. We end up getting a decimal approximation of 3 times 10. And we're going to divide that by 64, and then divide that again by pi. We end up getting 0.1492. 0.1492. 0.1492. And that is dr dt. So this answer right here, 0.1492, is actually in meters, because everything's in meters in this problem. So this is going to be 1.492 meters per second. And it says that I want it in, let's see, give your answers in centimeters per minute. I think it's per minute. Yeah, it's per minute. So this isn't per second, this is per minute. So if it's 0.1492 meters per minute, that's going to be 14.92 centimeters per minute. Now, that is dr dt. And dr dt is going to be the change in the radius. So in other words, that's b. I just found b. So let's go back and find a. Well, in order to do that, the easiest way to do it is to take this equation right here and do this. Let me erase this really quick. I can actually derive both sides here. dH, so in other words, dH dt equals 3/4 dr dt. And I know what dr dt is. Dr dt is 14.92. So if I plug 14.92 into here, then I end up getting 14.92. And if I multiply that by 3 and then divide that by 4, I end up getting 11.19. So dH dt equals 11.19. 11.19 centimeters per minute. So that's the easy way to find the other one after you know one of them.